Hello, Honors Math 1. This is Mr. Roberts at Shasta High School, and it's time to take a look at the Honors Study Team test. So we're going to go ahead and fly through the questions that appeared on this year's test. The first series of questions, the direction said, read the information below about several lines. If there is enough information, circle enough info. Draw a graph and find a rule, the equation or the rule. If there's not enough information, and I'll editorialize here, if there's not enough information to determine a unique line, tell what you would need to know. Tell what you would need to find a rule. So we'll start with the first one. A says that we are given line A apparently has a slope of -3/4, and it has an x-intercept at 7. So let's go ahead and draw kind of what we know there. So we'll begin with the fact that we have an x-intercept, and that's something kind of important to notice, right? That is a location. It's a location on the x-axis, and in fact it's the spot where x is equal to 7 and y equals 0, because all the points on the x-axis have y values equal to 0. So we have this location 7, 0, and that is x is 7 and y is 0, and I'm going to go ahead and put that dot on my graph. And we also have this slope pattern of down 3 over 4, down 1, 2, 3, and then over 1, 2, 3. This one is a little suspect. It's kind of off the graph a little bit, but I'll put a small dot there. Instead of going down 3 and then to the right 4, I could also go up 3 and backwards 4. 1, 2, 3, 4. There's a dot. I could go again. Oops. Whoa. It's up 3 and then back 4, and then I would go again. I'm sorry, up 3, 1, 2, 3, and then back 1, 2, 3, and 4. There we go. And again, I'll go up 3 and then back 1, 2, 3, 4. There we go. So there's enough points there now that it's just time to grab the ruler, and with the ruler I'll just kind of line it up with those points, and I can see that it's even doing an okay job of hitting my suspect point there. I'll just quickly draw that line, and one of the things I also want to make sure that I do is put on this line arrows that indicate it goes both directions, right? The domain here is all real numbers, and the range is actually all real numbers as well. This will continue to get larger as it goes back in time as x's are negatives, and it'll continue to get smaller as x's get a little larger. So I mean, we have enough information here to write the equation of this line. So let's go ahead and plug what we know into the equation of a line. So I'm going to write y equals mx plus b. This is a slope-intercept form of an equation. I'm going to plug in the fact that I have a y value from this point, right? A y value of 0. My slope is -3/4, and my x value from that point is the number 7, and then I'll just write the plus b. So this will be a great way for me to figure out what my y-intercept is. Let's see, 3 times 7 is 21, so I can rewrite this equation as 0 equals -21 over 4 plus b, and if I add 21 fourths to both sides, I get positive 21 fourths is my y-intercept. And we can see that, right? It's just a little bit, 4 goes into 25 times, and it's 1/4 left over. So this y-intercept is not 5, right? It's not 5. The y-intercept is at, it's at 5 1/4. So probably a good idea to make sure we understand that before we just look at that and assume the y-intercept is 5 and write the equation of that line down. So now, I don't know why, but my screen is gone. So now that we have that, interesting. As I was saying, now that we have that, we can go ahead and write the equation of the line here. So the equation of this line is y equals positive 21 fourths, right, which is what, 5 1/4. Oh, that's the y-intercept. Let's not start with that. It's y equals -3/4 times x, and then plus 21 fourths. So that's fabulous. That's the equation of the line. And also, let me circle here, there was definitely enough information to determine a unique line. Let's go on to B. B says line B passes through a point -6, 2 and has a slope of 1/2. So let's zoom in here to the point -6, 2. I'll place a dot there. and it has a slope pattern of 1/2. So I'll go up 1 over 2, up 1 over 2, up 1 over 2. Now, I'm completely confident that my y-intercept is 5 there, because as I was following that pattern, I clearly would land on that integer value. So the y-intercept is 5, up 1 over 2, up 1 over 2. And I will grab the ruler and go ahead and draw. Let me zoom out a bit, draw the line of the line of best fit. It's all these lines, all these points are on the same line. It's not a line of best fit, it's just a line. And again, add a arrow to each end, indicating that this continues in both directions. One of the things that, I mean, that's pretty much it. We can come up with the equation of that line. I'm confident it is y equals 1/2 times x, and then the y-intercept did hit at 5. But probably it might be a good idea to just verify that. So you could verify that by using the x and the y from this point that we have and the slope that we were given, and just plugging things into the slope-intercept form. So I would put down y is 2, for example, and the slope was 1/2, and the x value was -6, and then plus b, and then 1/2 times -6 is -3 plus b, and over here I've got the 2, and when I add 3 to both sides, yeah, I knew that was going to happen. So definitely there is enough information here. That's the graph of the line, and this is the equation of that line. Right, so let's move on to next page. It's the same question, so I'm not going to switch videos yet. We'll just finish up all of question 1 on this video. This next one says line C passes through 5, 4, and this point called the origin, right? And this point origin has an x-intercept of 0 and a y-intercept of 0. It goes through 0, 0. So that's going to be nice because it's easy to know what the y-intercept is. So I'll just plug in the origin point, and then this pattern from here is going to be up 3. Well, let me see. The other point that I know is at 5, 4. So I'm going to go over to 5, and then I'm going to go up to the number 4 right here. There we go. So if I take a look at this, right, there's definitely a slope that I can figure out. The rise is 1, 2, 3, 4, and the run is 1, 2, 3, 4, 5. So my slope pattern here is up 4 over 3, and the y-intercept is at 0. So let's go ahead and draw that line. Whoops. And I'm just going to use just those 2 points and draw the line that goes through there. And same thing, we'll again put the arrows indicating that this continues in both directions. And then as far as the equation goes, we can write a rule down. It is y equals, it was up 4 over 5 times x. I could put plus 0 if I wanted to. It does have a y-intercept of 0, but that's not necessary. So here is the equation of that line. There's the graph of the line, and definitely there was enough information there. Last one for question 1 is part D, and it says line D passes through the point 8, 2. So let me consider that 5, 6, 7, 8, and then 2. And at that point it's like, and what else, right? So the problem with that is that there are lots of lines that go through that point, right? That line goes through this point, this line goes through this point. In fact, there's an infinite number of lines that would go through that point. So it doesn't make any sense to say that I can tell you what the equation of the line is, because which line are you talking about? They're all lines that go through that point 8, 2. So there is not enough information here to determine a unique line, and I would not write a rule for it. However, it says what additional information is needed. Well, there's a lot of ways we can get around this, right? One of the things I could be told is I could be given the slope. A slope would be enough information with this point, or I could be given another point. And you know, another point could be different things too. I could say a y-intercept, but really that's a point. An x-intercept, that's a point. The origin, that's a point, right? So I need to be given something else. For example, a slope would be adequate with the point 8, 2, and then an additional point with the 8, 2 would be fine. Either one of those would be adequate.